Okay, so it's been a while since AIM as a cloud service has been out there. But do you know that the process of creating and customizing indexes is quite different in AIM as a cloud service as opposed to 6.5? In this presentation, we'll be covering how this process has changed. And okay, so hi, myself Mohit, and with me is my friend and colleague Nitin. We both are Jackrabbit developers, and we have been working on search and indexing for past 5 years. Okay, so here's a brief outline of what we will be covering in this presentation. First is the differences between AEM 6.5 and AEM as a cloud service. And because of these, how the process of customizing indexes had changed. Next, we'll cover OCPAL rules, and we'll dig deeper into indexing jobs. We'll also have a look at failed deployment pipelines, and then we'll conclude it with key takeaways.
OK, so we'll start. First, I'll talk about some key differences between AEM 6.5 and cloud service. One of the major changes that happened when we moved from 6.5 to cloud service was how AEM is actually deployed. On 6.5, we have dedicated servers for the AEM instances, be it on-premise or AMS. And with cloud service, we have a Docker-based Kubernetes deployment. On 6.5, we have a single node store, be it RMK or MongoMK. But with cloud service, we introduced something called a composite node store, which actually composes of different mounts that can be read-write and read-only. For, let's say, the author on the cloud service, we have a read-write node store that actually is on MongoMK, and then, a read-write node store that's on MongoMK, and a read-only that is on SegmentMK. Talking specifically about upgrades, on 6.5, the upgrades are performed in a maintenance window and you require a downtime. But on cloud service, we have an hot upgrade. It's basically your blue-green deployments to ensure that the service is never down. With specific to indexing, in 6.5, any customizations need to go into the original index. Whereas with cloud service, we have a concept of versioning in the indexes, and any changes or customizations to your index actually come through a newer versioned index. With 6.5, when you deploy or any change in the index, either your old index would work or the new one. But with cloud service, the old index would continue to work for the old code, whereas the new index will work when the new code is deployed on the new pods, basically. Now, lastly, with respect to a couple of other features, text extraction in 6.5 was performed by Oak. In cloud service, that is delegated to another service outside of AEM. And with regards to property indexes, on 6.5, you can actually create and update property indexes. But in cloud service, that is restricted. OK, so moving on. Index customizations in AEM 6.5. As I mentioned earlier, that any customizations in 6.5 need to be done on the existing index. And once we actually change an index, you require reindexing. And there are a couple of ways via which we reindex in 6.5. One is your online indexing, and then we have an out-of-the-band indexing. With online indexing, what we do is we make the changes to the index definition on an AEM instance, and then we set reindex is equal to true, and let the async indexing service take care of the reindexing process. Whereas with out-of-the-band indexing, we use the OCRun utility to update and reindex outside of AEM. Now, this process has significantly changed in cloud service. As I mentioned earlier, that the customizations on any index require a different version, a newer version of the index to be introduced in code. And any code changes in cloud service need to go through a deployment pipeline. Now, what this pipeline does, it has a lot of steps in it. But for the purpose of this talk, we'll just stick to the ones that impact the indexing. And two of the major ones are the OCPAL checks and the indexing job. First, I'll talk about the OCPAL rules. These are basically static checks to ensure that everything is right with the code that is being added in the deployment pipeline. With respect to indexing, this actually checks whether the incoming index definition changes are correct or not. depending upon the severity that has been set for the OAK-PAL rule, they could either log a warning or actually fail the pipeline altogether so that it does not go beyond that point. A couple of examples of the OAK-PAL rules for indexing are, I have a check on node type of an index must be equal to OAK:index definition. And then since AEM or OAK no longer does the text extraction for PDFs, etc., we ensure that the index asset leucine and any customizations of it, the Tika config actually is configured in such a way that it only enables the extraction for text files and no other data types. We have a lot of other OAK-PAL rules for indexing as well. We've attached a complete list in the appendix for your pursuit later on. Okay, now I'll hand over to Mohit.
Okay, so this is the main core component we'll talk about, indexing job. So this process is responsible for creating indexes, creation and customization of indexes. But before we start discussing indexing job, there are a few terminologies we should familiarize ourselves with. So as Nitin had mentioned that we use index versions to customize or create new indexes, we use an index naming convention to version the indexes. For example, let's say we have DAM asset 8 custom 10. Here, the base name is DAM asset, the product version is 8, and the customer version is 10. So what this means is we are basically customizing a DAM asset 8 index, and if you customize it again and again, we have to increase the customer version. So for example, let's say we have DAM asset 8. The next customized version would be DAM asset 8 custom 1. Next time if you want to customize it, it would be DAM asset 8 custom 2, and so on. Okay, so now that we know about index versioning, the next thing is comparison, index comparison. So which version is greater and which version is smaller. So let's say we have DAM asset X custom Y, and we will say this index is greater than DAM asset P custom Q if the product version on the first index is greater than the product version of the second index. In case both the product versions are same, in that case we look at the customer version, and whatever index has higher customer version, that will be considered as higher index. Okay, so now it's a simplified view of the indexing job. It basically taking into account what are the logical checks that we have in the indexing job. If the first thing an indexing job does is it fetches your indexes from the current deployment and new indexes from the deployment pipeline. That will and we first check if there are new indexes in the deployment pipeline. If there are none, we mark the job as complete. In case we find new indexes, then we first check if there is any index where the product version has changed. So if that's the case, there's another process which comes into picture, which is merging of indexes. So so here's an example for the merging of indexes. Let's say we have an existing index, DAM asset leucine 8 custom 9, and the new index which is coming is DAM asset leucine 9. So we do a three-way merging of these indexes, the out-of-the-box index, the custom version of the index, and the new version which is coming in. And we create another index, DAM asset leucine 9 custom 1. So this merged index is actually a conglomeration of DAM asset leucine 9, and we are basically picking the customization from DAM asset 8 leucine 9 and setting it on DAM asset leucine 9 to create this custom index. So keep in mind that in this merge logic, we are creating an index which is not present anywhere. So it is not present in customer repository, nor it is available on the out of the box. So this will come into the picture, and it can actually fail your pipeline next time as if you don't take care of these index versions, because your index version should be within some constraint. I'll show a few examples how it can impact in further slides. Okay. So once we have this merged index available, there are two other checks, logical checks present in the indexing job. So which basically put constraints on what's the index version you should have for the new index. So here's an example. Let's say we have DAM asset Lucene 8 custom 9. The valid index names for further customizing it is DAM asset Lucene 8 custom 10 or 12. So in this case, your customer version should increase. And some of the invalid examples are where you are changing the product version. So whatever is the out-of-the-box index, you should make sure that the product version remains same. And you are not decreasing the customer version. It should always be in an incremental manner. Please note that these are just examples. We only create one custom index in a deployment pipeline. So Nitin will discuss further with failed deployment pipelines.
Okay, thanks, Mohit. So as Mohit mentioned around the various restrictions on the naming conventions and how if you have an incorrect version of a new index, it could actually lead to a failed deployment pipeline. I'll just talk about a couple of examples. So now, deployment pipelines can fail due to a failure in the indexing job, and there could be a lot of reasons for the indexing job to fail. But today, I'll just talk about a couple of those, which as an AEM developer, you can prevent. So, I have a couple of log snippets over here. These can be downloaded from the developer console. When you run the pipeline, you will get the deploy step logs over there. So in the first instance, there is an attempt to add a custom index which has a product version that is lower than the one that is actually present on the system or the AEM repository. In this case, the indexing pipeline would fail, and the log is pretty descriptive, and it even suggests the correct index version that needs to be added. In the second case, what's happening is completely opposite. There's an attempt to add a new custom index which has a product version that is actually higher than the one that is present in the system. Both of these things are restricted and would lead to failure of the indexing job and thus the deployment pipeline. So we need to ensure that whenever we're adding a new custom index, the versioning is correct, and we should be cognizant of the fact that whatever product version is present on the system, we need to stick to that while adding a new custom index as well. Okay. So, and yeah, when all of these checks pass, the indexing job will proceed to indexing the content for the newly added index and will add it to the repository, and it will be available on the newer pods in the deployment for the queries to use. Okay, so now I'll talk about some major takeaways from this talk. First of all, as we've said multiple times, index versioning is a very important task. We need to be cognizant of the versions available on the system before introducing a new custom index. Otherwise, it'll lead to failed deployment pipelines, and we'll have to fix and rerun again, and it comes at a cost. Okay, and the last thing, do not update or remove out-of-the-box index properties. When we do so, effectively, we could lead to hampering in the out-of-the-box functionalities. Yep. Okay, so with that, we'll conclude this talk and have a happy indexing experience. Thank you.
Before we start our indexing experience, I've got two questions for you. One you covered already a bit, but I guess we have to go in more detail. It's about AEM as a cloud service merges all indexes, all asset indexes into a single index during deployment. Is there a way to define custom index on assets, or do you have any recommendation to work around it?
So this is not just for DAM asset indexes. Customization or the merging happens on any index where you have customized that index and a new product version index came in. This was mainly to not revert the customization that you had done, and there is basically no way you can do that, because if you we skip this process, the queries will fail. So it has to be done. The only thing you should keep before you customize anything is to make sure that what is deployed or what is currently available, you should see that, and that can be accessed from the developer console. You can get index definitions, and yeah.
All right. What happens to lower versions of the index once a new version is deployed?
Okay, so basically, when a higher version index gets deployed, the lower version would be present on the system for a while, but they'll not get picked up for the queries. And eventually, there is a background index purge job that runs on a timely basis, and it will clean up the older versions. Yep.
How do we index properties in AEM as a cloud service?
So basically, you could still use the Lucene indexes and define the property index for any property that you want. It's just that you cannot use the specific index type of property indexes which are synchronous. But to have a synchronous experience, you could even use hybrid indexes, which are basically you set sync is equal to true on the property. But we usually do not prefer that because it slows down stuff. And most of the use cases on search that we have on AEM, they could do well with eventual consistency, which is the model. By the way, we have another talk tomorrow in which we would be covering these topics as well.
Excellent. Looking forward to tomorrow.
Yeah.
Great to have you on stage. Big applause.
Thank you.
Thank you.